recording our talk.
אז שוב בוקר טוב לכולם, תודה שהצטרפתם להרצאה שמתקיימת במסגרת אירועי שבוע גישה פתוחה. I'm really pleased to introduce Milica, which I don't know how to pronounce your name, so your last name, so you will need to tell us to tell it yourself. But Milica is a project coordinator at EIFL and a librarian at the Institute of Technical Sciences of the Serbian Academy of Sciences and Art that is located in Belgrade, Serbia. As a member of the repository development team at the University of Belgrade Computer Center, she has been involved in the development of a network of institutional repositories in Serbia. She is also a founding member of the Open Science Community Serbia, a professional interest focused on open science. Library services aim at supporting research activities, training in academic services and tools, support to open access journal, information literacy, and research ethics. So please, Milica.
Hello, everyone. I'll share my screen first, and just to tell my surname because Sarit couldn't. It's Milica Ševkušic, but don't try to remember it. It's quite complicated, and it doesn't really matter. So I guess you can see my screen. Let me get back to the first slide.
Yes,
basically. Yes, my topic today will be the relationship between open science and artificial intelligence, and the reason why I'm talking about artificial intelligence, I'm not an expert on this topic, is that Sarit attended a boot camp organized by OpenAir, where one of the topics covered was artificial intelligence. The boot camp is dedicated to open science. We are discussing many issues related to open science. And last year, with the rise of these chatbots and all the fuss related to this, we decided to introduce a new topic. There were some discussions before this. There was a dilemma whether we should do this because none of us was an expert on the topic. And then we decided that it was important to cover this topic and to share what we already know, because we are all practitioners, we work with researchers, we train researchers, and it's very important for us to be informed. So at the beginning, when I started talking about artificial intelligence, I felt a little bit guilty because I'm not an expert. I'm not even from the IT environment. I'm a librarian with a background in the humanities, and I don't really know how these tools are made. I wouldn't know even to explain at the expert level how they work. But basically, we are all using them. They are around, they will be developing, and there are many issues related to them that we should know about. So that's my perspective today, and that's to let you know that I won't be able to answer any technical questions because I'm not that kind of expert. Briefly, you can download the presentation. It's publicly available, so you can use this code. I will tell something about the concept of artificial intelligence and how it developed, because it's not an entirely new phenomenon, although it's quite recent in terms, if you look at the length of world history, it's quite a recent phenomenon. Some concerns and challenges related to this, ethical issues. Then we will talk a bit about the relationship between open science and artificial intelligence and science in general. You will see that it's not easily separable, and present some uses and examples, and share a list of recommendations and discuss this topic a bit. So basically, what is crucial to the definition of artificial intelligence is that it's the moment of the ambition to imitate human cognitive capacities so imitating or even exceeding them. So that's crucial. There is a whole range of technologies that are similar to what we call artificial intelligence. But this moment that some applications, some technologies have this ambition to imitate human behavior, human reasoning, language interaction is crucial to the definition of artificial intelligence. So that's how we distinguish it in the area, in the sea of similar, technically similar apps and technologies. This is the UNESCO definition. There are many other definitions, and they all revolve around this crucial moment. So basically, there are also many timelines trying to explain the concept. So if you take the concept of imitation as crucial to artificial intelligence, you can project the term, and there are such histories of artificial intelligence that project the term to the ancient Greek period and some ancient philosophers who were thinking about various types of machines who could perform intelligence tasks, etc. Usually, in most histories of artificial intelligence, the period after the Second World War is mentioned as a period when the idea of the 1950s, and Alan Turing and some books that appeared at that time, they were related to the hype about the technology, the modern age, the machines, the fact that many tasks previously done by humans were automated with the development of technology and machines. And then there was a rise between the two world wars. There was a rise of science fiction, which continued after the Second World War. And there at that moment, this idea was a kind of adopted in science about machines who could think and about automating some logical tasks. And then there were some developments there. And one of the moments that is also, you will see it mentioned in histories as a crucial moment, was 1997, when there was a series of chess games played by Garry Kasparov, who was the world champion at that time, chess world champion, and the machine Deep Blue. And that machine actually managed to defeat Garry Kasparov at that moment. And basically that was considered as a milestone in the development of artificial intelligence. But there are different, this is one of the timelines with different machines, and you will actually see that there are many steps, that this is a process, that what we are seeing now actually was developed some years ago. So for example, one of the moments that we usually don't realize that it's closely related to what we have today with chatbots is the development of these personal assistants used Siri or Cortana or something like this. So the same technology underlies these tools. But what is interesting about this timeline and the next one is this term, the winter of AI, and you can see it here. So to me, it was interesting because in most histories, it's not that extensively discussed, but this term means that at these time periods, during these decades, there was a kind of slowing down in the development of artificial intelligence, and this was due to some abrupt halt of funding. And this is usually associated with some disillusionment with artificial intelligence, because, you know, when such things start to develop, there are many expectations, and if some experiments fail, or if, I don't know, some expectations are not met, or if there is a kind of a crisis and the money is invested in other technologies or in wars or in, I don't know, healing the economy that encounters issues, then there is insufficient funding for projects dealing with artificial intelligence. And this is usually the development is less extensive or it's even stopped. So this is something that we should think about today, because we are dealing with this hype with artificial intelligence. This is not impossible that at a certain point in time, such a new artificial intelligence winter may occur. So this is an option that we should take into consideration. To me, it was interesting because if you usually when you look at the timelines, you see the kind of development rise. There is an idea of continuity, but this is not so. So there are ups and downs and some repeated efforts, etc. What is crucial, and that is one of the reasons why another AI winter similar to those in the 20th century is not that likely today, is the fact that digital technologies and the internet enabled the creation of huge amounts of data, and data are crucial to the development of artificial intelligence, because if you're dealing with trained algorithms, then you need huge amounts of data, and this is something that we now have available, quite easily available. Of course, there's many issues, I will mention this a bit later, related to the use of this data, but now we have increasing amounts of data, and the technology currently can support, in most cases, can support the handling of these huge amounts of data. So basically, this is another diagram. I usually use this one. I try to find, and there are nice diagrams showing artificial intelligence, but many of them are not in open access. They are not under a free license, so I can't use them. So this one is fairly good and explains the main idea. So what is crucial? The crucial feature of artificial intelligence is this ambition to mimic human behaviors. And there are some areas where, and you could see them also on the timelines, where these artificial intelligence tools are particularly developed, and where the explorations into artificial intelligence are more mature than in some other areas. So this is robotics. These efforts started in the 20th century. There is a extensive development now. Natural language processing, which is the key topic and the key area for what we will be talking today, and vision intelligence, which is also closely related to the things we are mentioning. So there are many tools. With the development of computers, there has been this ambition to make it possible for users to communicate with the machines using the natural language, because if you're communicating with machines, you need to know coding. Also, if you're a librarian and you're doing search, then you need to know some rules. You need to structure the search strings in order to make it possible for a machine to decipher what you're searching for. So this ambition to make machines speak human language and make them able to process natural language and prompts in natural language and search strings in natural language is actually crucial. And it's natural that there is a huge development in this area. So this is another diagram related to artificial intelligence that I like to show, because when we say artificial intelligence, then this is not one unified concept. This is a very diverse diversified area where there are many subfields, and there are many classifications, and these classifications are usually defined from different perspectives. So you have, for example, classifications that are related to particular research areas. There are those related to types or maturity of applications, or the intentions, etc. So these are some of the areas, and you can see those that I mentioned, for example, computer vision, it has sub-areas, robotics, natural language processing, but we have automated planning and scheduling, also knowledge representation and reasoning. This is a huge area. Machine learning. So this is also crucial to our topic, where actually machine learning means we are teaching machines. We are making machines learn using data to first, there is this kind of supervised learning where machines are fed with annotated data sets where it's indicated the correct selections, answers are indicated, and then they are led to unsupervised learning where they make predictions on their own based on what they already have learned from in the process of supervised learning. There is also deep learning, etc. So these are developing concepts, and we will now focus on this types of AI. We will explain it in greater detail, because it's also crucial to our today's talks, and it's also crucial in terms of explaining what the phenomena, recent phenomena that we are facing now. So it's this is very interesting to me, so because we usually talk about artificial intelligence as something that is developed, that already exceeds human capabilities, which is not actually the case. So now, according to this classification, we have, this is the classification based on capabilities of artificial intelligence. And we have three classes, three categories. One is narrow AI, and the other two are general AI, super AI. General AI and super AI, they exist only as theoretical concepts. So we don't have examples of this. This is something yet to be achieved. And we are still in this area of narrow AI, which is also called weak AI, and this is the only all the applications that we have belong to this. This is the only type of AI that has some tangible outcomes. So basically, it is based on training machines, training apps to perform some narrow tasks or even a single task, and they can't go beyond these tasks. They can't do things that they are not trained to do. Theoretically, these more developed types of artificial intelligence could be able to do this. For example, there are some statistical tasks that humans still perform better than the artificial intelligence. And if you go and test these tools that are available, you will see those limitations. And it's very important to be aware of these limitations. So all these virtual assistants that we are using, they all belong to this narrow, and everything that we'll be talking today belongs to this narrow AI, which is the lowest level of AI development. Now, another crucial term that is very important for us to understand, especially since the last year and the launching of these popular chatbots. ChatGPT, which is hugely popular, and then Google's Bard, which is now called Gemini, and other stuff, and Bing's tool. So it's the concept of generative AI, and it's based on deep learning models, and basically the feature of this type of AI is that it can generate text, images, and other original content. So it's original because it's disputable to what extent it's original, but it's basically it can be described as original in terms that it's not the same. It's not a copy of some other thing. It might contain elements of other things, but it's not a copy, and it's generated by the machine based on the information that machine contains in itself. And another term that is also important to understand is the large language models. So it's a kind of a subset of deep learning. So you see that these classifications are very, very complex. So basically, and another crucial concept in natural language processing. Machines are trained to to communicate with users in the natural language, and they can recognize the prompts. So when you type a prompt in the natural language, they recognize what you're asking them to do. They can translate from one language to another. They can even make some predictions. They can generate text, and they can generate images. Sometimes they can generate tables based on the data you give, convert PDFs to, I don't know, PowerPoint presentations, etc. So they can perform these tasks more or less successfully. And also they can produce some plausible information that is sometimes, I could say quite often, false. And what is a problem? It's usually culturally biased because the results of this process of communication with such tools are based on what is in the tool, on the data that are used during the training of the tool. So I will explain this in greater detail later, but basically, if the data come from a particular part of the world, from particular sources, and the data is already biased, then the outcomes, the results produced by these generative AI tools will inevitably be biased. So that this is, for example, when you the simplest test that you can perform yourself is, for example, to ask an AI tool, a chatbot, to generate some images, and you will see, for example, the distribution of different races. Mostly the people shown in these images generated by generative AI tools will be white, and males will probably prevail. So and there are other types of bias that are sometimes more difficult to identify without a closer look. So the hype about artificial intelligence, well, there has been a hype for several years, but last year it actually exploded with the tools that I already mentioned. And what is important is that these tools are for wide use. They are not for scientists. They are not for a limited group of people. They are available to the public. And they are, to a certain point, they are free. So ChatGPT, you have a more developed version that is paid, but basically you can use it for free. And it's a bit limited, but you can still use it. And the hype was actually what is in the background. So I said that mimicking is a crucial moment in understanding artificial intelligence. And this hype actually fed, it started feeding our myths that we rely on, that are deeply embedded in our culture. So we have those Pygmalion myth, Pandora myth, we have millennialism, millennial fears, the end of the world. We have alchemy. So this image that I'm showing on this slide, it was created by Bing's tool, and it was created based on a prompt. I don't see that it's really very successfully created. I don't even like it visually, but some people react to this. Some people are excited about this, very optimistic. They tend to overestimate the abilities of AI, and some people get frightened by this. For example, we have teachers in schools who don't know what to do with students' essays, and that's quite an issue. And you can see that in science, in the area of research and in development in science, there are many issues. There are many texts, blog posts, research papers published about this. This is a rough selection of these. They are all quite recent, published since last year. And there are many concerns related. Some of these concerns are related to the public area, not strictly related to research. For example, in media, you have those deep fakes, videos created by videos and images created by AI, where you can't really it's very difficult for an ordinary observer to identify whether it's a real video or not. And social media are flooded with this type of content. Also, we have use in schools, in universities. So there are ideas to ban the use of chatbots and some companies and at schools, etc. We also have this in research. So basically, now it's this is increasingly often mentioned. One of the phenomena related to chatbots and actually to artificial intelligence tools is the paper mills, because the papers are generated using a computer-based tool, and they're not checked. They usually contain fake data or irrelevant data or fabricated data, and they pass peer review because probably peer review is not carefully enough done. So they get to journals, and then they get retracted, or they don't even get discovered. So this is quite an issue. And we are talking about crisis, and we don't really know how to deal with this because this is quite a new area. We don't really understand. Many researchers don't understand. Journal editors don't understand. Peer reviewers, they don't know how these tools, they need additional training in order to be able, and more experience in order to be able to deal with this. So this fact that this is a new area for all of us is additionally adds to the challenges and difficulties we are facing. Also, there are many challenges in the area of research integrity and image manipulation, data fabrication, etc. But there is also another area of research integrity and ethical concerns, and this is that there are tools that claim to be able to identify the use of artificial intelligence tools in research papers and images, etc. And they are using the same technology, and very often they actually make wrong assessments that leads to false accusations of students, of researchers, etc. So this is also another tricky issue. Basically, there is a wide range of ethical issues related. I mentioned some of them, but the problem, a huge problem that we are dealing with is the lack of legislation. So we don't even know how to deal. We don't really have policies. So in some institutions, you don't even know how to deal when it's discovered that somebody used or misused artificial intelligence tools. You don't even know how to deal because you don't have a policy on this. And you don't have a policy because you don't have a general experience to rely on. There is no legislation, and the legislation is now being developed. So, for example, there are copyright issues there, and they have many aspects. For example, one of the aspects is the use of copyrighted materials to train. So there are lawsuits filed against OpenAI, for example, because they used copyrighted materials. But it's difficult to prove that they used, and it's difficult to interpret this in line with the current legislation on copyright or on intellectual property rights in general. But also, there is another aspect of copyright, how to treat the images created by chatbots and different other tools based on AI. Can AI have can an AI tool bear copyright? Can they be responsible? So according to most national legislations, they cannot, and all the publishers currently rely on recommendations that say that only a human can be an author and only a human can be accountable in relation to the content of a paper submitted. But perhaps one day this could be difficult, different. So there are many differences. Also, the quality of data is huge, and you will see in relation to open science, this is highly relevant. So if you have dirty data coming from a limited number of sources, for example, social media data or data from some apps that are used in particular parts of the world and that are not curated. So basically, what you get as a result will be limited or will be poor in quality. One of the examples in this area is multilingual content, because basically if you test chatbots, you will see that they perform much better in English than in other languages, because the greatest part of the data used for training was in English. And small languages, and especially the languages not using the Latin alphabet, will probably be a sort of, there will be a kind of bias, they will be less represented in the data set used for training. And if you try to use chatbots in these languages, they will perform worse than, for example, in English. So basically, another challenge and another area that is usually disregarded a bit is that the role of disciplinary knowledge, because if you are creating artificial intelligence tools that will be used in some research areas, then you need to have disciplinary knowledge. And the problem is that people who have disciplinary knowledge don't necessarily have the IT skills, and the people having IT skills normally don't have a particular kind of disciplinary knowledge. So this is another issue that you should take into account when discussing and assessing these tools. As for the risks and challenges, I won't discuss this in detail, but there is a very interesting blog post, and there is a book behind it, published by Petar Jandrić. He works at the in Zagreb at the University, the Faculty of Applied Science at the University of Zagreb. And some of these risks are actually they are not that technical, and they should be taken into consideration. For example, he's talking about conformity and about the potential loss of individual thought, intellectual diversity, and the decline of creative thinking. Because when you start using these tools and you overestimate their capabilities, you might come to depend on them. You might start using them even if you don't need them. And then basically you lose the chance to, I don't know, come to a certain conclusion or a discovery. Some discoveries in science are not are accidental. So if you are relying too much on these tools, you may lose this ability. You may lose a chance to come to an unexpected discovery. You also your creative thinking, it will probably decline. You will start underestimating your own abilities, and you will feel comfortable in using, relying on these tools. So this is really very important. And also the fact that these tools, they are not expanding, they're fed with some information and they are limited. They're using this information that is in them, and they don't go outside to find new information when you ask them a question. This can lead to a kind of dogmatic thinking. And this is a huge social and political risk if you consider this seriously. So I highly recommend reading this, at least this blog post. So as for science, there is a very good book. It was published last year. It's quite detailed, and it covers different areas of science. And here I listed only those that are related to the development of tools. And there is a diagram in this book that I'm using, which explains the complexity of the relationship of artificial intelligence and science. So we all know, though we tend to forget this, too frequently, that the history of artificial intelligence in science didn't start last year with the rise of popular chatbots, but there have been this development that extends since the previous century, and this color coding is used. So the deep blue circles, ellipses, they represent the direct use of artificial intelligence in scientific research, and the other colors indicate a different kind of relationship. So you can see that artificial intelligence is used extensively in scientific research. So it's data processing, data visualization, simulations, all sorts of stuff in citizen science. And I will now go just to show a selection, a random selection of examples, because there are many, and I will draw your attention because the relationship between open science and artificial intelligence is also very complex, and it goes in both directions. So there are quite some points of encounter when we talk about the relationship of open science and artificial intelligence. So artificial intelligence revolves around data, and it can't exist without data. So open science that advocates for the sharing of data, opening up of data, is actually enables us to feed with new tools, with data. Open data is used to train algorithms. This is a common practice. So if you produce good quality, high quality data, you can improve the quality of the algorithms. Also, artificial intelligence tools are used to process data, and they are commonly used, and I will show some practical applications. There are some open science projects that developed, an increasing number of them, that developed artificial intelligence tools. And also open science has benefited a lot from software and hardware that was developed in in artificial intelligence research. So some of these tools that are developed in artificial intelligence research are open source or are available in other ways, and they can be used in open science and in scientific research in general. And also, when we talk about ethics, open science focuses on ethical issues of responsible research and innovation. And one of the aims of open science is to increase the credibility in science, to improve the integrity of science, and to actually rely heavily on ethical principles to improve the integrity of science. So that is where open science can actually contribute to make artificial intelligence better. I highly recommend visiting this link, which explains the position of European Research Agency on artificial intelligence. And there you can also see some examples, some documents, and examples of some projects. I will mention some of them. So in brief, one of the tools, I will now list some tools that are used in research and in open science also, open science research. Chatbots are quite often used, and they are very appealing, and it's understandable why they're appealing. I already mentioned they're using the natural language, and they produce responses in human language, and sometimes these responses really look like human responses, and they can serve as personal assistant. And researchers have started using these tools, not always in line with ethical principles, but for example, you can use these tools to improve the text. So you can add a prompt saying improve, summarize, shorten, extend, etc., and you will get a kind of output that you will probably have to edit, and you will probably have to review it and to revise it. And what is important to know is that if you want to have a better result in the communication with a chatbot, you need to adjust your sentences, your expression, your linguistic expression, you will have to adjust it to a machine. Because if you are using a language that is too complex, there is a high risk that what you get as an outcome won't be sufficiently accurate. So this is one of the risks that are mentioned by Petar Jandrić, that you don't even feel this. You change your language, just like, for example, when we talk in English and it's not our mother tongue, we tend to use simpler phrases. And then this also affects our expression very often in our mother tongue. So this is a similar process. So this leads to a kind of reduction in terms of the complexity of expression. You can also use them for translation. They are not always equally efficient, and in writing literature reviews. So basically, I already mentioned some of the challenges. The most important one is that you don't have any, often you have this effect of black box. You don't really know what's the reasoning behind the response you get from the tool. So you can't even assess whether it's reliable or not if you don't know the subject, if you're not a kind of a discipline, you don't have disciplinary knowledge. And also the problem of hallucinations. They are now trying to reduce these hallucinations, and they've been successful compared to the last year. But basically, those large language models, they just invent. They don't do the search. They just invent the response based on what they have, what they're fed with. This is a list of chatbots and academic tools, and I will show a few of them so you can use them as writing assistants, and you can use them as search engine. This is a promising area, but still there is a lot to be developed there. And these tools are usually not free, so they have a kind of limited free access, but they are not free. The Solicit tool, this is probably one of the best, and it uses a technology that involves some communication with beyond the limitations of the data that are fed in the large language model. So it's a bit more advanced technology. Site, this is not free, but this is one of the better tools that you can use. For example, you can add a prompt in the natural language, and then you can get a summary of research in this area. Of course, you will have to check all of these. There are also custom chatbots, and this is an increasing trend. So OpenAI, although they are a commercial company, they enable researchers to use their code to develop custom chatbots, and this is one of the examples. For example, in nanomaterials, this researcher developed a tool, but there are many examples of open source chatbots, so this is also a promising area, because these chatbots, those custom chatbots, they will be created by researchers, by people who have disciplinary knowledge, and they will probably be able to contribute to the development of the area. Virtual labs, this is also another promising area. Virtual labs are virtual environments where you can perform tasks, whole workflows. You have data there, you can process data, you can make simulations, and actually it saves a lot of money. It's fed, virtual libraries are fed with the disciplinary relevant information, and here you have some where you can try them. Some of them are free, so they're really, really useful. They are based on those large language model technologies and other technologies as well. In citizen science, there are many applications. I'm sharing this one, PlantNet, because I'm using this. It recognizes plants based on the information fed into this. And here you have some links where you can get more information about this. Healthcare, we saw with COVID what happened, because huge amounts of data were shared. So this is a kind of a personal assistant. And there is also a project, it was finished last year, that was funded by the European Union, and that actually was focused on open science, on artificial intelligence and on open science in healthcare. All data-intensive areas have those close relations with artificial intelligence, and they have in both directions are those relationships. So they can feed the data to artificial intelligence tools, and they also use artificial intelligence tools, and they sometimes create artificial intelligence tools. So this one will end this year. It's related to wildfires. Also in genomics, it's an area where a very advanced area in terms of use of artificial intelligence tools, ocean research, climate change, climate research in general. So all these data-intensive areas have close relations with and artificial intelligence has some history of use in these areas. There is also very interesting ongoing projects because European Open Science Cloud is all around, it's related closely to artificial intelligence, and this is an ongoing project related to these technologies. Unfortunately, EOS portal won't be available for some months, but in the autumn you can check there, you can find quite some interesting tools that are based on artificial intelligence. And now I will just present a list of recommendations. You can explore this list. What I can say about this, that this is a very active area. So we have a kind of proliferation. This is not a right term, but we have a growing number of recommendations, and they are still recommendations. They are still quite frequently revised. Because the area is changing. So the area of artificial intelligence is changing. There are new tools on a daily basis. There are new challenges on a daily basis, new challenges that are discovered because you need to use a tool in order to be able to discover what it can do and what kind of, I don't know, fraud people can invent using these tools. So you need to keep an eye on these recommendations and to keep on checking whether there are some recommendations. This will remain so in a few years. So for example, in publishing, basically you cannot sign, you cannot list a chatbot as an author, but these recommendations have changed during the past year because what at the beginning was like no, now you can use some tools, but then you have to be very transparent about their use. So a good idea is to check recommendations before doing anything that is related to these tools. You need to, anyway, you need to be very transparent. So about the takeaways, there is a hope that open science could help create more responsible artificial intelligence tools because open science focuses on ethics. The principles of open science could act as a corrective mechanism in artificial development and use. So there is a lot that open science can contribute to artificial intelligence and open science can benefit from artificial intelligence in terms of using tools, data, improving the quality of data, making simulations that wouldn't be, for example, all the a great deal of the research carried out by CERN wouldn't be possible without simulations that are relying on artificial intelligence. So basically, this is what I had to share with you today. And now I guess that we have some time for questions, and there might be some already.
So thank you, Milica. There are a few questions in the chat.
Yeah, they're about the presentation. Yes, it's already available. I will share a link with you. And you can reuse it. It is under a free license. So if you need, you can reuse it. So basically, the only thing that I have to say in conclusion is that we must talk about these topics, although we are not experts. We need to be informed because the chatbots are so widespread that the practice used in some schools, for example, in my country, forbidding the use of these tools, it doesn't really work. So if you don't know what's in it, if you don't know what it generates, you wouldn't be able to recognize it, and there is no point in actually forbidding anything.
There is another question. I want to ask how integration AI in open science can support development citizen science. I think it was a question that was posted at the beginning, or you already talked about it a little bit. And another question, how AI in open science contributing to improvement scientific knowledge among poor and low socioeconomic groups of population.
Yeah, so basically the key point in improving the less privileged ones is the openness and open source code, for example. So in my opinion, the key to improving the equity is the access to tools that you, for example, you have open source tools, and you can build upon them. You don't have to buy them; you can build upon them. The code is open, the data are open. You have access to publications. For example, a colleague of mine at my institute here in Belgrade, he tried to do. He's doing nanomaterials, biomedical materials, and he wanted to do research that is related to make some predictions, etc. And one of the barriers that he encountered was copyright, and the fact that we didn't have access to papers that he wanted to analyze. He created an algorithm, but he couldn't feed it with relevant data because we didn't have access to these publications. So, for example, if you have open access publications in open access available, and if they are in a suitable format deposited in repositories, researchers who are creating artificial tools based on artificial intelligence, they can use this material. The same applies to data. So you have data, open data under an open license in appropriate formats. This can be used to create. You have open source software. So that's where actually open science and everything around it help to give a chance to less privileged ones. And also the open science, I already mentioned this, the data produced in various projects all over the world, open data, could improve artificial intelligence tools because they can help diminish the bias. Because if you have data from different communities, from different parts of the world in different languages, and you feed the tools with these data and train the tools using this data, the results that what these tools generates will be less biased. And also about citizen science. Citizen science is a promising area, and there are many tools that are applications that are based on artificial intelligence that are already available and that are open source. And for example, the one I mentioned, it's about plants, but you have similar applications about insects, about clouds, about all sorts of stuff where citizens are involved in scientific research.
Yeah, I can tell you that yesterday we had a presentation of the founder of Retraction Watch. Did you hear about the database?
Sure.
And yeah, he mentioned that one of the problems that caused the rise of retracted articles are AI. People that using researcher that using AI in order to write the paper, and they try to publish it and they succeed, and after that they are retracted.
So yes, these are these paper mills that I mentioned. This is quite massive, but if I may say, it opens up artificial intelligence. Well, this is a symptom. So this is not a reason. This is a symptom of a crisis. And there was an essay about schools saying that perhaps we should abandon the type of essays that we are using, the types of testing that we are using. So why not invent something else? Also, there was an article, it was published some months ago in the London School of Economics. They have a very good blog and they often discuss artificial intelligence there. And this blog post, it discusses a book that says that basically many researchers are currently using those artificial intelligence tools to draft papers. They use them for writing. They are not using them for some more advanced tasks. And why? Because they need this for career advancement. They need it for career development. In order to be promoted, they need to publish papers. So, and they are using whatever is available. Previously, they would pay to someone, to a ghostwriter. Now they're using chatbots for free. So this is a symptom. This is not a reason. And we need to find a different type of solutions. So why not publish data without having to write an article and go through, why not changing the research assessment systems? These are the ways to deal with this, not abandoning AI tools.
Yeah, I mean, the next presentation today is about responsible metrics, so
yeah,
goes directly.
So there is, I mean, this is something that is, because publishers, they are still having huge profits, and they benefit from keeping this inefficient system of scholarly communication alive, and that's an issue. That was the same with predatory journals. So people would say, so it's about open access. So there wouldn't be any predatory journals without open access. It's not true. There are journals that are of poor quality and they're not open access. So it's not related. This is just a symptom of a crisis, and the source of the crisis is elsewhere. It's not in artificial intelligence.
Yeah, totally. There is another question in the chat. When can we do AI chat to all academic literature? Is this not the ideal? How can we achieve it? Example, training on all academic literature, semantic scholar limited.
I believe that the other technologies that are not AI are not mature enough. For example, this is the problem of interoperability. And it's not necessarily AI related. So, for example, in order to be for a tool, any tool, to read a paper that is in PDF, the format has to be proper. Some technical requirements need to be met. So that colleague of mine that I mentioned, he had to, in order to process the data from the papers, the information from the papers, he had to text recognition, optical text recognition, because he was using PDFs. So the most publications are not in an appropriate format. Some of them are scanned, some of them are digital born, but they are not following standards. You have multilingual content, you have different alphabets. So look, for example, at the references in the Web of Science. So I'm a librarian primarily, and whenever I do a citation report, I find that about 10% of the citations for a colleague of mine, for example, are not discoverable because they are not parsed accurately and the machine cannot find them. So this is not AI related. We have chatbots, but we have previously unresolved issues related to interoperability. For example, the text processing tools that we are using, the tools that we are using to create books, and the readability of this text, machine readability of the text that is produced in this way, they are not optimal. So also persistent identifiers are not widely used. So they are crucial. The metadata, so already at the metadata level, you have issues. So we need to solve many, many problems that are not related to artificial intelligence in order to be able to feed chatbots. And perhaps one of the ways would be to abandon some inefficient areas of scholarly communication and to think in the direction how to achieve direct use of data. For example, if you have data sets, you don't need to extract data from papers. You publish data sets. So many researchers still publish supplementary information with publishers. They are not under a free license. Sometimes they're even paywalled, although you don't transfer copyright to publishers for these outputs. And many researchers still do this, and they shouldn't. They should publish research data in line with the FAIR principles in repositories and make them available whenever possible under a free license. So when we achieve all these steps, then we can discuss about chatbots using this information. And that's where open science can contribute to the development of AI through the development of infrastructure and the improvement of interoperability.
So the comment of the comment to your answer is a nice answer. Thanks. So it's a good way to finish the event. Thank you so much, Milica, on a really fascinating presentation. You give us a lot to think of, to think on, sorry. And thank you again for joining.
Thank you for inviting me. So basically, we still have many human social issues to solve before making artificial intelligence really, really efficient. Thank you very much.
Thank you.
Thank you.
Bye-bye.
Bye-bye.